everybody, and welcome back. And in this video I want to introduce you to a library that comes in Python, which is called the crypt library. So let us see how we can actually import that library. First of all, open your Python 2 interpreter, since we will be using it in Python 2. Now you can also use it in Python 3 if you want to, but you might need to actually pip3 install crypt. So in order to import it in Python 2, all you have to do is actually just type import crypt. So it comes pre-installed. You will not have to install it for Python 2. Let me just check if it actually comes pre-installed in Python 3 as well, so we can actually try to import it there as well. And you can see that it actually does come in Python 3 as well. So let me first of all zoom this in so you can see it better. And what this allows us to do is actually make or to encrypt a password in plain text with a salt value. Now, a salt value allows us to actually encrypt the same word with the same crypt function, but to actually have a different value, hashed value, once it actually finishes the encryption. That's why it uses salt. So the same word will actually, with different salt, have a different encrypted value at the end of the process. So let me just show you. If we make a variable, for example, called word, and that word is just admin, for example, so we have a string attached to this variable, and that string says admin. Now let's use a value called crypt word. So this is a variable that we will use to store the crypted word, or encrypted, with the crypt function from our crypt library. All we have to do is just type crypt.crypt, and we can specify the word in the brackets separated by comma with the salt. Now the salt will be 2 letters that you specify between the double quotes. So let me just show you. If I just type here hx, for example, then finish it with double quotes and press enter, you will see that if I just type here print crypt word, you can see that we get something different from the word admin. But you might notice that it actually has the first 2 letters the same as our salt. So if we, for example, wanted to do it once again, so we want to use a crypt function, so crypt.crypt, and want to use it on word, whoops, and right now what we want to use is a different salt, so let's use the L. For example, you can use any 2 letters you want, close the brackets, type here enter, and if we actually print the crypt word once again, you can see that the value is completely different from the value of the previous crypted word, which we actually encrypted the same word, which is just admin. So this is more advanced actual technique to encrypt the passwords, since allows or prevents hackers from actually being able to brute force the passwords once they're using salt. Since if they find the hash value of the value admin, they can actually have multiple hash values for that word, since the salt is applied to that process. Now what we will try to actually code is we'll actually try to code the brute forcer for the crypt library, or we will try to brute force a certain word which is encrypted with this crypt function right here. But in that process we will actually know the crypt value, since we can notice right here, or the salt value, since if we look right here, we know that the salt value will always be the first 2 letters from the word that is encrypted. So we can see that right here we use the hx as a salt for the encryption, and we can see that the encrypted value actually had first 2 letters to be hx. Now then we actually try to use the DL, and we can see that the encrypted value at the end had the L as first 2 letters. So this allows us, even when we see something like this, to know what the salt is of that encrypting process. So we know that the salt was the L, which then we can specify of our program that we know the salt, and we can encrypt every password from our password list with the same salt, and then we can actually try to compare it to this salt, to this encrypted value right here, and if they do match, we found our word in plain text. So let us see how we can actually do that. Let us close this right here. let us nano crypt force.py, that is how we will name it, since we are actually brute forcing a password that is encrypted with the crypt library. We add the user bin Python as usual, and we import our crypt library right here. Now, first of all, let us start by actually creating our main function right here, which this function, what we will do, it will actually prompt the user for the password file, and then basically that user will input the password file and we will read from that password file. But let's first of all, before we do that, create the password file itself. So save this, even though we didn't code anything, and let's remove the pass.txt from the previous video. Since we will create a little bit different password file, we will create the password file that actually contains both usernames and passwords, just the passwords will be encrypted with the crypt library. So let us go to the Python interpreter, import crypt. For this demonstration, we will actually use our, let's say, basketball, since in the previous video we used football. So basketball is the word, and encrypted word will be crypt.crypt. We want to encrypt the word, and we want to use, for example, the salt, which is GH. So just specify it like this, print encrypted word, and this is our encrypted word basketball with salt GH. So let us copy this, we will put it in our password.txt file. Nano pass.txt, so we will nano a new file, and here we can actually specify anything, so admin password. Now imagine all of these values are actually hashed with the salt from the crypt library. So admin password 123, admin, root tour, root passwords, root, and then we add the hashed value right here. Then we can add admin root, and so on and so on. So the point of our process is that once it reaches right here, it will notice that this is the GH, which stands for salt, and then it will try to encrypt the password basketball with the actual password list that we specified that contains words. So this is the first program that will actually use two different files in order to crack it. This is the file which actually contains the password that we want to crack, and the file that we will use from which we will be brute forcing, we will name something like dictionary.txt, and then we will actually encrypt every password from the dictionary with the same salt value and compare it with these values right here from these passwords. So let us save this. Let us nano a dictionary.txt, and here we can just type your password, root, admin, football, hello world, and then let's add basketball. And then admin once again, or admin123. Now this is our dictionary, this is the file that we will use to brute force the password, so let us save this. We have these two files right here, dictionary.txt and pass.txt. Now let's not make sure to not confuse ourselves with that, so basically I will explain it once again. But for now on, what we want to do is actually first of all open the password file, and by password file I mean the file that will actually contain the encrypted value, so we will call it pass file equals open, and then we will simply just open the pass.txt. We can open it for reading, or we can actually prompt the user to specify the file, so no, it doesn't even matter, since you can just type here raw input or whatever you want if you want to actually prompt the user for the actual password file. But for now, let's just use this right here. Since we only have one password file, it doesn't really matter. This is just for the demonstration purposes. And what we want to do is for each line in this password file, so this is something that we are familiar with, we use it a lot, so for each line in passfile.readlines, since our pass.txt file is separated with usernames and passwords by the two dots, we first of all want to separate the username and we want to get the password from that. So if we can just do if this in line. So if this is found in line, what we want to do is we want to make a user variable to be line.split by the actual two dots, and we want to make the user to be the first part of that line, and the password will be the second part of that line. So let's call it crypt password actually, since we will pretend that all of those passwords are actually encrypted with the crypt library, even though only the one for the basketball is, but it doesn't even matter. This is just for demonstration. So line.split, we want to split it by two dots. We want to use the second part of that line, and we want to strip it from any, for example, spaces that are there, or from any new lines. This is something that we must always include, the new line, since this character, even though you can't see it once you open the password.txt file, it is there and it will present problem if you do not remove it. So for now on, let us just print the actual crypt pass in order to see if we successfully removed everything that is unnecessary in our file. So let's save this, but first of all we need to code the calling of the main function, and let's actually make this an executable. So cryptforce.py, chmod it, and then we need to run it. We will run it right here. Global name crypt pass is not defined. So print crypt pass. Let us see why is it not defined. Oh, it's not crypt pass. It's not crypt pass. It is crypt word. Pardon me. So crypt word. We will print it right here, and this is good. So we got the passwords without the new line characters. So we get it right here. This is the value that we are looking for. This is what we want to actually decode to be a basketball. I believe that was the word that we are looking for. So all we have to do right now is first of all go back to our file. We want to remove the printing of the word since we don't really need to print it. Now we know that it is good. So what we want to print is, let us print cracking password for, and then add the username which we are cracking for. So the user variable is the first part of the line. So we will want to crack the password for that user. And then let us use a function called crack pass. That's what we will call it. And we will pass to that function our crypt word. Now this function doesn't exist, of course, so let us code it up here. So crack pass, we need to name it the same as in the code itself. So crack pass. Let's first of all make this a small letter. So not capital, and this crack pass will take the crypt word as an argument. So it will take the crypt word as an argument, and first thing we need to do, as I said before, we need to declare what is an actual salt in this password. So an actual salt is the first two letters of the crypt password, and the first two letters we can select like this. So salt will actually be the crypt word, and the crypt word from the first letter to the second letter. So this is how we can actually create the salt variable to actually contain the first two letters of our crypt word password. And all we want to do right now is open the dictionary file, which we can actually select as dictionary. I'm not really sure how we can spell it. Dictionary equals open, and then we will open our dictionary.txt for reading. So we opened our dictionary, and what we want to do for every word in this dictionary, we actually want to first of all strip it from the new line as always, and we want to crypt it with this salt right here and compare it to the actual value of the crypted password. So let us do that. So for every word, for word in dictionary, for word in dictionary dot readlines, First of all, we want to make sure that the word equals word.strip from the new line character, since we do not really want that. And right now, what we want to do is actually crypt the word with the actual salt. And we can call that right now crypt pass, since we use the crypt word variable already. So our crypt pass will be equal to the crypt.crypt from the word from our dictionary with the salt. So salt we selected right here. So this should be good. And all we have to do right now is actually check if crypt word equals to crypt pass. So if our crypt word that we got from here, so this crypt word right here, from our pass.txt file, which is encrypted with the salt, if it equals to the crypt pass, and crypt pass is the variable of the password that we use from our dictionary with this salt, then we found the password. So we will just print found password, and we will add the word in plain text. So we do not want to add the crypt word, we want to add the crypt, just the word. So this should be good, I believe. And all we want to do from here is just return to the main function, since we successfully finished this function. And in case that doesn't happen, we want to print password not found. And then we also want to return back to the main function. So if I'm not mistaken, this should work. And right now, if we just save this, we have our dictionary.txt right here, pass.txt. And if I run the crypt force, let me just see, cracking password for admin, password not found, cracking password for admin, password not found, root, basketball. So we managed to actually find the password right here, which is not really that noticeable, so we will fix it with the term color right now. But let me just check something first of all. So okay, so it is good. I was a little bit confused why it cracked 3 times for the admin and 3 times for the root, but then I realized that we actually specified the admin 3 times as the first username and the root 3 times as the first username. What I am concerned about is this password not found, so let us just see why that happened. Why did it say password not found? Let's actually return the word. Let me just check whether this will work. Okay, so that doesn't work. For some reason, it prints out password not found, but we can fix this easily. With the else, and then we want to print password not found. But no, this shouldn't actually be like that. So let me just think about it. We will iterate over every word in the dictionary, so we do not want to print it right here. Let's see what happens if I just run it like this. Cracking password for basketball, found password. Oh, I think I know what the problem is. I should have printed it right here. Let me just try it. Password not found. Let us try right now. I'm not really sure why does it. Oh, okay. So yeah, since we call this function multiple times down here, we do not want to specify it right here. We want to specify it, oops, right here. Think about this. If I quit right here, and then print. Oh no, let's actually return right here. I'm sorry for this, but sometimes even I get confused about these silly things. So let me just see where we can actually add it. Print, or not print right here. So password not found. This is really that big of a deal, but it is always good to have everything specified correctly. And we do not want it to have it like this. So what we want to do is actually type it right here, and let us run this once again. But we still do get password not found, even though it is not anymore printed after every username. So let's actually now fix the actual colorization. Term color import colored. This password not found, we can actually, so we can do it like this, return true. If let's try it like here, if crack password, then pass, else print password not found. Now this is really not that. Let me just see, no module name term color. From term color import colored. Okay, it doesn't really matter at the moment. Let me just run this once again. Okay, so for some reason it doesn't even matter, so we'll just not print this password not found. Can't really think about it right now. It is not really that important. What is more important is that we actually specify the colorization so we can more easily notice the actual password if we find it. So colored, we want to print this in red. Make sure to always use this as a Python 3 since term color is in Python 3. Here we want to just return, and here we want to print this in green. So we will print this in green. We close the double brackets right here, but then we unhash this statement right here. Let me just save this right now, and right now if I Python 3 this, name y is not defined. What? Oh, so here I specified by an accident y, so let us just see it right now. Okay, so we do find the password, so it is basketball with our crypted value. So let me just cat the pass.txt. We can see that this value right here is equal to basketball, which is actually correct since we specified that at the beginning of the video. So that would be about it for the password cracking section. We didn't manage to actually fix this, which is basically just continuing to crack even after finding the password, but it doesn't really matter. It isn't that important. Maybe later on I will actually try to fix it and show you how I did it. But what is more important, that in the next section we will actually start off by actually attacking or coding some of the attacks in our local area network. So we will try to code the R spoofer, the packet sniffers, the FTP credential sniffers, and a bunch of other programs as well. So hope you enjoyed this password cracking section, and I hope I see you in the next one. Bye!